Hello, fifth graders. I hope that you are having a wonderful Wednesday. This is the second time that I'm doing this video because what happened is the first time I loaded this up onto YouTube, there was no sound. So we're going to do it again. So I'm sorry if you logged on there before and had a little trouble. So today, after you watch this video, you're going to go into Success Maker and you're going to look for Summer School, 5th grade math, June 17th. Okay? Alrighty, so today we're going to be talking about fractions. Actually, these next 2 weeks, because we only have one more week after this, we're going to be looking at fractions. And we're going to start with the idea of what fractions are and equivalent fractions. Okay? After you get done watching this video, there will be an activity to do, which would be Summer School, 5th grade, math, June 17th, because today is June 17th, and then we have our Zoom meeting at 11 o'clock. Okay? Unless you're watching this later, then we already had our Zoom meeting at 11 o'clock. Alrighty, so let's take a look at just a regular fraction. Now, a fraction is made up of two things. On the bottom, we have a denominator, and on the top, we have a numerator. Now, the denominator is usually easy to figure out. The denominator is going to be how many sections something is broken up into, how many pieces something is broken up into. So let's take a look at this fraction up here. I'm going to find out my denominator by counting how many sections it's broken up into. 1, 2, 3, 4, 5, 6. So there are 6 sections. Now, the numerator is where you have to be more careful. You have to be more careful because the numerator can be a couple of things. In this, it could be two things. It could be how many sections are shaded in or how many sections are not shaded in. You don't always want to assume what you're doing in math on a question or on a test because they can change directions, and if you're not paying attention, you end up getting it wrong. Okay? So let's say I want to know the fraction that is shaded in. So I'm going to count how many of the 6 sections are actually shaded in. There is 1, 2, 3, 4, 5. So my numerator is going to be 5. And I would say this 5/6, right? Because usually for your denominator, you add on that THS at the end. 5/6, right? Now, if I had asked how many sections are not shaded in, that would change my answer, wouldn't it? If they asked how many sections were not shaded in, then there's only one section that's not shaded in. So if the question asked how many sections are not shaded in, that would change my answer to 1/6. Notice the denominator did not change. Unless I change the number of sections in the whole thing, the denominator is always going to stay the same. Okay? Alrighty, now what I want to do next is I want to take a look at some equivalent fractions. Now, equivalent fractions is a more complicated idea than just regular fractions, but it still uses the same ideas. Okay, so if you think about equivalent fractions, when I work with fractions, I find out that sometimes what looks like the same amount, I can use different numbers to describe that same amount. A really common example is 2/4 and 1/2. If I draw a picture of 2/4 of a circle, and I take the same size circle, and I draw a picture of half of that circle, I'd see the same amount is shaded in, so that I can say that 2/4 and 1/2 are equal. Or the better math word is they are equivalent. They are equivalent. Okay? So let's take a look at a fraction. Now this right here has 1, 2, 3, 4 sections. So I know that my denominator is 4. And I want to know the amount that is shaded in. So I'm going to count how many spaces are shaded in, or sections are shaded in. 1, 2, 3. So if somebody asked me what fraction is shaded in, I could say 3/4. All right? Now, I can split up these boxes. I'm going to leave the same amount shaded in, but I'm going to split these boxes into more pieces. So I'm going to draw one line across, and I'm going to draw another line across. Now, I changed the amount of boxes in this whole thing. So this does change the denominator. Remember, I get my denominator by counting how many sections are in the whole thing. All right, so let's count how many sections are in the whole thing. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. I'm counting how many sections are in the whole thing, so I'm not worried right now about how much is shaded in, just how many are in the whole thing. And there are 12 sections in the whole thing. Now, I want to know how many are shaded in, so I'm going to go back and just count the boxes that are shaded in. 1, 2, 3, 4, 5, 6, 7, 8, 9. So I can see with 12 boxes and 9 shaded in, I would describe that as 9 twelfths. 9 twelfths. Okay? Now, let's take a look at this. Did I change the amount of this rectangle that was shaded in? No, I kept the same amount shaded in. So where before I had 3/4 was shaded in, I didn't shade any more in, I just added more boxes and I got 9 twelfths. So I could say that 3/4 is equivalent to 9 twelfths. 9 twelfths. If I change the amount of sections but I don't shade any more in, I'm going to get myself equivalent fractions. Okay? Now, it's not always practical to draw a picture of fractions. Now, when you just get started, I would strongly encourage you to draw pictures of your fractions, just because when you can draw pictures of a fraction, you also can kind of picture it in your mind, and being able to visualize math is very important, especially with fractions. Okay? So, drawing pictures to start out when you're working on these problems is a great strategy. It's a great technique. But like I said, in some cases, it's not always practical. So I want to show you another way to make equivalent fractions without the picture. Okay? So if I have a fraction such as 1/3. But I want to find an equivalent fraction that uses 6. Say it's like candy and I have 6 kids to split it up instead of 3 kids. So I want to make an equivalent fraction for 1/3 that uses 6 as the denominator instead. Well, if I want to make equivalent fractions and I don't want to draw a picture, I can multiply or divide to make equivalent fractions. So in this case, I need to get from 3 to 6. How do I get from 3 to 6? Well, I know I could add 3, but when we do equivalent fractions, we're not going to add or subtract. We're going to multiply or divide. So I'm going to need to multiply to get from 3 to 6, because 6 is bigger than 3. What do you think I would multiply 3 times to equal 6? Did you think 2? Because that's right, 3 times 2 is 6. Now, you're going to hear me say this a lot, but I'm going to say it again. When you're doing something with multiplication and division to a fraction, and you're trying to make equivalent fractions, whatever you do to the denominator, you also have to do to the numerator. So if I multiplied my denominator, the bottom number, times 2, I need to multiply the numerator, the top number, times 2 also. What is 1 times 2? It's 2. So I could say that 1/3 is equivalent to 2/6, and I proved it because I multiplied the same number by the numerator and denominator to get it. Okay? You also can divide. So let's say I have 4/8, and I want to figure out how many halves that is. Okay? And that might seem, you might have already figured that out in your head, but let's pretend for a minute you did. Okay? What am I going to do to get from 8 to 2? Well, 2 is smaller than 8, so I'm not going to multiply 8 times something to get 2. I can divide, though. 8 divided by what equals 2? Did you think 4? If you thought 4, you were right. So I'm going to take 8 divided by 4 and get 2. Now remember, I told you you're going to hear me say this a lot. Whatever you do to the bottom, you do to the top. Whatever you do to the denominator, you got to do to the numerator, or vice versa. Right? So if I took the denominator, 8 divided by 4, I need to take the numerator, 4 divided by 4. And what is 4 divided by 4? Do you know that? 4 divided by 4 is 1. So I could say that 4/8 is equivalent to 1/2, and I proved it because I took the denominator and the numerator and divided them by the same number to get my new fraction. Okay, so I proved that that was right. I didn't just guess, and that's what we want to do in math, right? We don't want to guess. We want to be able to prove our answers are right. Okay, so let's talk about today real quick, okay? So after you get done watching this video, of course, the next thing we have is our assignment for today, okay, which would be summer school, 5th grade math, June 17th. So make sure you look for that in your Success Maker. And we have our Zoom meeting at 11 o'clock. Like I said, this is the second time that I've uploaded this video because the first time there was no sound. So maybe you're going back to watch this video now. Right, so maybe you already went to the meeting, and that was great if you did. Okay? Either way, I hope you have a fantastic day. Thank you so much for watching my video. Like I said, have a great day, and I'll see you later.